Okay, so let's unpack this one. Today, we are diving into a really interesting problem. How do you possibly send a high-speed USB signal, we're talking 10 gigabits per second, over 164 feet?
Yeah, that's way beyond standard limits. Copper USB cables, they typically give out around, what, 15 feet maybe?
Exactly. So our focus today is this Kramer cable, the CP-AOCU32-AC 164. It's built specifically for that huge distance. And it goes from a standard USB-A connector on one end to a USB-C on the other.
Right, and the core thing for you, the listener, to grapple with is that technical challenge. Pushing USB 3.2 Gen Yo speed, that full 10 Gbps, over 164 feet. Copper just can't do it. The electrical signal, it attenuates, it just fades away.
It's just physics, basically, resistance.
Precisely. So our mission really is to figure out what specific tech they're using to get around that fundamental problem.
So how are they cheating physics then? The source material we have calls it a hybrid cable. It says it mixes copper wires, presumably for power, with fiber optics for the data signal.
That's the key. It's a hybrid approach.
It even gets specific, mentioning a 2-channel OM2 850mm VCSEL array. Now, that sounds like a lot of engineering jargon.
It is, but it tells us exactly what's going on under the hood. That VCSEL array. That stands for vertical cavity surface emitting laser.
Oh, okay.
Lasers, tiny lasers, yeah. They essentially convert the electrical data from the USB port into pulses of light. Light traveling down those OM2 optical fibers can go much, much further without losing the signal integrity compared to electrons in copper.
So the fiber handles the data, the copper handles power.
That seems to be the setup. The fiber does the heavy lifting for the high-speed data transmission over distance.
And the result is that headline speed, 10 Gbps, USB 3.2 Gen 2 super speed plus WALF. That's impressive. But here's something that surprised me a bit. The power. You'd think a, $400 plus active cable this long would need its own power supply.
Right, you'd expect a wall wart or something.
But nope, it says no external power needed.
Yeah, that's a big deal for usability, especially in professional installs. It pulls all the power it needs right from the USB source device. And the consumption's actually really low, less than half a watt, via 0.5 W according to the specs.
Wow. Okay. So high-tech, long distance, but still plug-and-play power-wise.
Exactly. And it's also backward compatible. Works with USB 3.0, 2.0, even USB 1.1, though. There's a small catch there.
Oh, what's that?
Even with this fancy optical tech, the really old USB 1.1 standard is still limited. The spec sheet says only up to 50 feet for 1.1 speeds.
Ah, okay. So the fiber helps most with the high-speed stuff. Makes sense. So this specialized hybrid cable, what's the intended use case? Who needs this?
Well, the sources point to things like professional USB cameras, maybe in studios or large venues, conference room gear like speakerphones, remote printers,
Yeah.
situations where you need reliable data over distance.
Okay, so professional, data-heavy peripherals. But if it's this capable for data, why does the source material also spend time listing what it can't do? There seem to be quite a few limitations.
That's where the engineering trade-offs really become clear. They had to focus to achieve that core goal, 10 Gbps over 164 feet. So the spec sheet is very explicit. This cable is for data transfer only. Meaning absolutely no device charging through the cable. You can't use it to power up your phone or tablet. It's just not designed for that power delivery.
Okay, data only, no charging. What else?
And this one's critical.
Yeah.
It does not support ALT mode signal.
Alt mode, right.
Yeah.
For listeners who might not know, what does that mean in practice? What can't you do?
It means no video. Simple as that.
Yeah.
You know how USB-C can sometimes carry DisplayPort or HDMI signals?
Yeah, connect a monitor directly via USB-C.
Right. This cable cannot do that. They completely sacrifice that alternate mode capability, likely to ensure the integrity and speed of the primary USB data signal over that extreme distance.
So data only, no charging, no video. That really narrows the use case, doesn't it?
It does. It's a highly specialized tool for a specific problem.
And looking at the physical side, despite having delicate fiber inside, it seems built for installs. 4.8mm diameter, high crush resistance.
Yeah, they clearly expect it to be routed through walls or ceilings, potentially. It needs to be somewhat robust.
Which brings us to the value snapshot. This isn't cheap. The price mentioned is $432 currently.
Oof, yeah.
And it comes with a 3-year Kramer warranty. That price point definitely signals professional gear, not something you grab off the shelf at a big box store.
Absolutely. And that price really underscores the point. To break that 15-foot copper barrier for 10 Gbps USB, you're moving into a different class of technology. You're leaving passive copper behind and entering the realm of active optical solutions, which are inherently more complex and, well, expensive.
So the breakthrough here is essentially using light instead of electricity for the data, enabled by that hybrid fiber copper construction.
That's the core of it.
Yeah.
Active optical conversion is the key.
It really is an impressive bit of engineering, solving a very specific, challenging problem. So maybe the thought to leave you with is this. If getting just data at 10 GBPs over 164 feet requires the specialized $400 plus active optical cable, and it still can't handle things we often take for granted with USB-C, like video or simple charging, what does that tell us about the hidden complexities and maybe the costs still involved in pushing data faster and further? It really highlights that transition point, where everyday copper infrastructure just hits a wall and you need to step up to dedicated, professional, and often optical solutions